Okay, welcome back to our next lecture video that really focuses on the USPNF. And in this, maybe short, maybe not so short, who knows by the time that I gab and talk for hours at a time, you know how I am by now. But for at least for a bit, we're going to formally talk about 191, which is the chemical identification test that's found within the USPNF. So the chemical identification test, there is a chance that if you've taken our CTC 114 course, which is our wet laboratory techniques course, you have gotten a taste of what chemical identification tests are. So chemical identification test is really just qualitative analysis, folks. That's all that it is. And look, I'm getting so tired of writing. I just gave out on you. Chemical identification or chemical ID test is just really a formal way to talk about qualitative analysis. And qualitative analysis, back in the day that we talked about it in the 114 course, was just observational based. That's all that they are. So these are observational based tests that we're going to add a few things to most of the time. And then we're going to write down what we see. Does it cause a precipitate? Does it turn color? Does it generate heat? Is there bubbles present? What's going on? That is what identification tests mainly are, but identification test goes more than just observations. So yeah, what most of it is reagent based, observational based, qualitative based, but there's a little bit of instrumentation that can be found in the chemical identification test as well. So we're eventually going to talk about some of that equipment, some of that instrumentation, but we're going to have our own videos that are dedicated to those particular types of tests. And the only thing that we're going to be focused on here in this series of videos is 191 as it's stated in the USPNF. All right. So if I go to my USPNF textbook or my online reference source, because most of it's online now, and I go to the section of 191, which is identification test, general is what this says. This is where all of those tests are going to be pulled from. So for instance, if I pull up, let's say, the hydrochloric acid monograph, and I look at the hydrochloric acid identification section on the monograph itself, it's going to say, here are some identification tests that we can do, and it's going to reference me to this section most of the time, but not every time. So here's an example of the HCl monograph. And up here at the top, it gives me some basic information about HCl. So that's going to include the chemical compound, the CAS number, the formal name, maybe other names that it's known by commonly will be listed here. Definition, it says hydrochloric acid contains not less than 36.5% and not more than 38% by weight of HCl. And then we get a section, and this section, ta-da! Says identification. So that identification section is what we're going to be focused on, and that's what our lecture videos are going to all be about. And the majority of the monographs that are included in the USP will have a identification test in the very first thing of the very kind of beginnings of the monograph. It's very upfront, it's very kind of frontward facing, and this is typically the section that you get to first. The reason is because this identifies the compound that we're using. I hope that makes sense, right? So for instance, in other words, if this is really hydrochloric acid, then we better have a test in the very beginning that better be short, sweet, and simple and easy to do. And if it is short, sweet, and it's easy to do, then we can go on with the rest of the test. But for this particular monograph, for instance, this is hydrochloric acid, and some of the identification tests will play a role in the chloric piece. It's going to look for chlorine. So if I come down and I look at the identification test, I'm going to see identification test 191, general, chloride. So that means that I'm going to do a test to measure the presence of chloride, because this is hydrochloric acid. And if it's hydrochloric acid, then chloride should be present. If I do this test and it fails the chloride test, then that definitely means we don't have hydrochloric acid. We've got something completely different. So if I think this is hydrochloric, then that definitely for sure should have chlorine in it. And this identification test is going to help me ID that material, and it's going to play off of the chloride part of that molecule, and chloride should be present, which means that I would get a positive test here for this particular identification test. It's telling me chloride should be there, chloride should be part of this, you should have chloride present. That's what the identification test, that's what it's all about. So notice it doesn't give me any other directions in the identification test here. It just says identification test, comma, general, chloride, 191, and that's it. So notice this looks like a hyperlink. So if I was reviewing this information online through the USPNF, which is how it's done most of the time now, I would just take my little bitty mouse and I would go over and I would click, and then all of the identification tests would pop up for me so that way I could reference to them. So that general identification test, it's going to look something like this. So when I click that hyperlink, this is what's going to show up, and it gives me some information about what the identification tests are all about. So I'm going to go through this introduction here in just a minute, but notice in the hydrochloric acid monograph, it says the ID test for chloride. So if I scroll through this section, I'm going to see quite a bit of different cations and anions that are listed here. And these are typically in alphabetical order. So chloride starts with C, so I'm going to scroll until I get to the C section. But notice there's bunches of these things, right? So I'm going to get to the chloride, and here we go. And it says chloride, and then it says A. With silver nitrate TS, solutions of chloride yield a white curdy precipitate that is insoluble in nitric acid, but is soluble in a slight excess of 6-normal ammonium hydroxide. Then it gives me a triangle, whatever that means, and then it ends with a triangle. All right, so this is how I find the proper steps for the identification test that we need to do. So that's where this lecture is all about. And before we go a little bit further, I'm going to go back to the brief introduction paragraph that you saw in the very beginning of 191. So again, here's 191. These are general identification tests. And there is a section that is called a chemical identification test. So there's two different categories here. And the very first one that we're going to be talking about is our chemical version of ID test. Typically what these are, these will require some type of reagent, and that reagent is going to be added to a solution of the material that I am testing. So typically things that I have to make or things that I have to order. It could be more than one thing that I have to make or order, and more than one thing can be added to these test tubes in order to get these reactions to take place. But overall general idea is that they are chemical-based tests, which means kind of the qualitative analysis scheme that we saw in another course if you've taken that class already. All right, so a little bit about the identification test. Number one, if you read that paragraph in the very beginning, so right in there, if you want to save yourself some time, then I'm going to let you do that. Here we go. That's all that we got to do. So I'm going to kind of go in and talk a little bit about the important details of the background sections of 191. So 191, if you read that paragraph, number one, they are going to allow you to scale the volumes if needed. Meaning that if the recipe is written to make 100 milliliters of a reagent or 100 milliliters of a sample or whatever the case is, then you can scale that up or down as you see fit based on your company needs. So if you don't need to be wasteful and you don't need to make a lot of stuff, then you are more than welcome to double or to halve the things that are listed within the identification test. So volumes are allowed to be scaled if needed. So that's a good thing. But if they are scaled, then most of the time a company has to provide you with an SOP in order to make those reagents or solutions, meaning that we don't trust you with the math. So the USPNF is going to give you directions and recipes on how to make these things. And if you read those recipes, you weigh out what they tell you to weigh out, you put in a solution that you wanted to put it into, then that's great. There's very limited think work that goes in. You just got to measure some stuff out and dissolve it. But if you do need to be scaled, then there needs to be an SOP in place for that scaling piece, because we cannot trust you to double everything or to have everything and do the math the proper way. So on a sheet of paper, there will be a reference, and it will say reference this recipe, or this is how you make this reagent, and it might not quite match the USPNF's recipe, but it will be scaled proportionately. All right. Next, you can do instrumental test. So instrumental test is going to be like version number 2 of the identification tests that are out there. So we do have a chemical version, reagents, drops of stuff, milliliters of stuff, tell me what goes on. And then we also have an instrumentation side of the house that we can analyze solutions on, and that piece of equipment or that instrument can tell me what is present and what is not present. So you can use instrumentation test in lieu of the chemical test if you need to. So the problem, and maybe not a problem, just a little bit of extra work that we've got to do in a laboratory environment, is that if we do choose to use the instrumental version of the test, then folks, they've got to be validated. That equipment has to be validated. It's got to go through a more formal process of making sure that it's working and that it is operating the correct way. Because if we don't validate that something's actually performing the way that it needs to perform, then the data that comes from that instrument really can't be trusted. So a validation is going to be totally different in a different lecture snippet. We'll learn about validation at a later time, but just keep in mind that this is the drawback for the instrumental test. So the instrumental test, because of the validation piece that has to go on, some of the instruments will require a little bit longer runtime, and time is always going to be an issue for the instrumental part. So very often, I know it doesn't seem like all prim and proper and fancy, but the reagent-based or chemical-based identification tests are much more convenient. They are easier. They are quicker. Within a matter of 1 or 2 minutes, we can add those reagents to my test tube and kind of see what it looks like. And in the other side, if we've got tons of different samples to process, then that's a lot of stuff for me to keep up with. So the instrument pieces will actually come in more convenient in that manner. So this would be great if there were tons of samples that were submitted to the lab that maybe all need a chloride test in this particular example. And then we can just run everything on the instrument all at once. And then I can walk away from it and do something else and then come back to that instrument once it's finished. Next thing that I think that I have to mention in that introductory paragraph is that if you do the chemical versions of the identification test, that is fine. That's kind of the go-to for most of us. But if you do that and that particular ion or cation that you're looking for has multiple tests that are listed, then all of those tests have to be performed. That is what the monograph tells us here. So all chemical tests, ding, 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 all chemical tests listed for the ion shall be met, unless the monograph tells us something different. So for instance, here is a snapshot of zinc. So if I had a material in a laboratory that needed a zinc identification test, because zinc should be present and we should be able to pick that up, then this is what I would see in identification test 191. Under zinc, it has A, B, and C. Because it lists A, B, and C, that is what this particular step is referring to. All chemical tests listed for the ion shall be met, unless it tells us otherwise. So if normal circumstances, we were measuring zinc, we would have to perform step A, step B, and step C. You do not get the choice of doing one or the other, or 2 out of the 3. You have to do all 3, in this case, that are listed before you can say, yes, zinc is present because I completed the chemical version of the identification test. That is a have to. So if the material that we were working with, though, says zinc A or zinc B or zinc C, and it specifically states that, can I get by with just doing that one test and that test it? So for zinc's example, in the presence of sodium acetate, solutions of zinc salts yield a white precipitate with hydrogen sulfide. This precipitate is insoluble, meaning it doesn't dissolve, in acetic acid, but dissolves in 3 normal hydrochloric acid. So it would have to pass A, ting ting, and we give it a check mark. And then we got to go to B. Ammonium sulfide, TS, produces a similar precipitate in neutral and alkaline solutions. And then in C, with potassium ferrocyanide, zinc salts in solution yield a white precipitate that is insoluble in 3 normal hydrochloric acid. So all 3 of those would have to be performed. All 3 of those would have to be documented. All 3 of those we would report observations on what we saw. All 3 of those we would sign off on, unless it tells us otherwise in the specific monograph that we were working out of. So I keep talking about qualitative analysis, right? This whole kind of concept of qualitative analysis. If you took 114, you did qualitative analysis. You might not remember what qualitative analysis was, but in case you don't, here is the review of kind of a summary of what we were doing back in the day. So qualitative analysis is based on these reaction schemes that for the most part generate a precipitate. And the precipitate was something that we tracked. A precipitate is something that we recorded and that we talked about throughout the time. We separated the precipitates out and did further tests on those precipitates. That was qualitative analysis back in the day. So if you did not take 114, that's what you missed out on, and that's what you will see when you take the 114 course. But this is our kind of an abbreviated qualitative analysis scheme during that time. So we took a mixture of various things that were inside of a sample chamber that was given to us, or a sample tube that was given to us. We added a little bit of acid and we got a precipitate that formed. And that precipitate had all of what we called group 1 ions. That acid addition could be a general identification test 191 step, because that acid will precipitate out silver chloride and mercury 2 chloride and lead 2 chloride, because I see all of those chlorides over there. Hence why when we look at the hydrochloric acid monograph, that identification test for chloride is going to say add acid, and when you add the acid, if chloride is present, or whatever the case is, silver nitrate, add silver nitrate, and if you add that silver nitrate in our HCl, then that silver nitrate will precipitate out the silver chloride and make a precipitate that we can see in the test tube. So in the lecture portions of the laboratory assignments, where we start breaking down a little more detail of the test that you did, we'll talk about that into more detail, but this is where really a lot of the chemical identification tests originate from. All right, so I don't want you to memorize this. I don't want you to kind of take notes on this. It was just really a quick review with anything, especially for those that have taken 114. If you've not taken 114, it's something that we'll talk about maybe in more detail when you do that lab experiment. So here's another example of 191. This is with barium, and barium says step A, solutions of barium salts yield a white precipitate with the addition of 2 normal sulfuric acid. So again, just like before, we're playing off of these reagent-based tests, and we're playing off of really a solubility chart. So if you've taken general chemistry, maybe in high school, or general chemistry 151 or 152, there's typically a section that talks about a solubility chart. And it's like, okay, well, if you've got this and you add this to it, a precipitate forms, and a precipitate forms because it's not soluble in the solution solution anymore. So it falls out and it settles to the bottom of the test tube. So this is really where, again, these things are going to originate from, which is how that qualitative analysis scheme was built. And in this particular case, if you think you have barium in solution, so here's our barium, and you add sulfuric acid to that solution that has barium on the inside, that sulfuric acid carries with it SO4. And barium and SO4 can come together, and it can generate a product called barium sulfate. So if barium is present, sulfide madly falls in love with the barium, just flickers its little eyes and be like, oh, barium, you're so handsome, or you're so pretty. Let's come and make a little couple and let's fall out of the solution. And that's what sulfate does when it gets added to the test tube. And these two things marry almost immediately. I mean, goodness gracious, it's faster than a Britney Spears marriage. And then that barium sulfate will fall out of solution and it forms a precipitate. And we know it's a precipitate because there's an S there, and that S stands for solid. If barium is not present in our barium-containing sample, then barium will not react with the sulfate. And if barium is not present, and if barium does not react with the sulfate, then no precipitate is going to form. And then we go, uh-oh, there's no barium in my sample. I'm going to have to figure out what this thing is. And then maybe we go through that motions. But really, for the monograph pieces, we do the test that's listed, we pass it, we fail it, and we move on. And if this fails, then there's no sense in testing this for anything else, because the major player, right, that's what this is all about, the major player, which maybe is barium in this case, is not present. And if that's not present, we don't have the stuff that we think we have, so we just completely stop all the tests from that point on, and we go on to something else. The same thing happened with maybe the zinc example that you saw a while ago. If I did the presence of zinc because I had a zinc containing compound, and I do these, and I do not get a positive reaction here, I don't do anything else with that material because zinc is not present. We tested for it, it wasn't there, and if that's not there, then it automatically isn't what we think that it is. And the same thing for hydrochloric acid monograph that I pulled up a while ago. If I added, or if I did the chloride test, and that chloride test did not tell me, oh my gosh, you've got chloride, you get a Y precipitate. If I don't get it, chloride's not present. Why would I do the other test of the monograph? I'm just not going to do it. Yeah, now maybe I'll double check myself. Maybe I'll do that test more than once. But again, the idea here is that these are major players, and we are looking for the major players in the chemical identification test that we are seeing, and the instrumentation identification test as well. That's what we're looking for. All right, so these tests are very simple. There's not a lot of think work that goes behind them. Again, drip, 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 down into a test tube. That's all that I've got to do. And then I will watch for things to happen. So I really make observations. I record those observations, and I call it a day. That's all that I have to do here. And that identification test has now been completed. So these are meant to be very quick test, very simple test that provides you with the identity of the compound in just a matter of minutes, for the most part. Now, there's always exceptions, but for the most part, that's what the identification tests are all about. So I think that what I have to do here is stress, make observations, right? I mean, that's the thing. You want to make observations because these are identification tests. And if you don't write down what you did, and if you don't write down what you saw or what you observed, then what good is the actual test itself? So you want to make sure that your documentation pieces are actually in line with where they should be, and observations and writing those down is one of the most important things that you can do when you do these tests in real life. So don't forget those, please, right? Observations tend to be forgotten, and I feel sorry for them sometimes, and they feel very lonely. So I want you to give observations a little bit of loving, and those observations will be very happy, and they'll be so glad that they got included in your discussions, and an auditor will be so glad that you included them in your discussions, because if not, then that auditor is going to go tattle, and they're going to be like, they are ignoring observations every single day, and observations are just sitting in the corner being all boo. And then that auditor is going to tell your supervisor, you just need to go fire them, and you'll be the one in the corner going, boo, I'm going to jump. So make sure that you write down the observations. All right, here's example number 2. This is the chloride piece that I referred to with the hydrochloric acid. So here it says, with silver nitrate, solutions of chlorides yield a white curdy precipitate that is insoluble in nitric, but soluble in slight excess of 6-normal ammonium hydroxide. So keep in mind, I keep referring to the HCl monograph. And the HCl monograph, you know, that's great. Yeah, absolutely. But that's only one thing that has chloride present. I mean, there's tons of things that have chloride out there. And if it has chloride, then this test is fair game. So I'm going to see multiple things referencing 191 chloride test possibly throughout the entire monograph textbook or reference book. Tons of material that could have chloride present in the structure. HCl is just one of those. So instead of writing the same step every single time, one again, I mean, don't be like Bart Simpson on the opening sequence, right? You're not going to write down the same sentence hundreds of times, and the USPNF is not going to do that either. So HCl is really the one that we do in our lab, typically in the very first thing, and HCl is what you're going to see first. That's why I reference to it a lot of times, but anything that has chloride in it would possibly have General Identification Test 191 referencing this step, right? What I want you to focus on here is the highlighted piece. And the highlighted piece starts at the triangle, and notice the triangle ends here. Those triangles are very important because that means alert. I mean, that's what that is. So I'm going to read this sentence and I'm going to be like, oh yeah, that seems really simple. And then I see that when testing amine hydrochlorides that do not respond to the previous test, add 1 drop of diluted blah, 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 blah. Okay, that triangle area is typically a notification that a change has been made in the entries. So as you can imagine, these tests do get updated over a course of time. These tests do change. If there's better ways of doing them, they get updated. If they found mistakes or if they feel like the wording of the statements are kind of then they'll go in and maybe fix that up a little bit. And whenever they do these changes, they often will give you a triangle symbol like that for an alert or yield. So, I mean, that's kind of what we would see on the road. Maybe it's just upside down, but it's still yield, slow down, hold up. Now let's take a look at and see what the sentence is. So that way, if you were performing this particular piece of the general identification test, they are letting you know, just double check it, please, because something in here could have changed from the way that you've been doing the test, and we want to make sure that we are alerting you of that change, and that's the way that they do it. If you're on the online version, sometimes they will highlight those areas, not just put triangles, but they will also highlight them to bring more attention to them, but that's what that is all about. So keep in mind that when you do pull these up, it's very important that we are following the current rules, not the rules from 2022 or 2021, that we're following the current ones that are set in place in today's laboratory environment. And if there are changes, and that can be common, then they will symbolize those with those triangles and those highlighted areas for you if you are accessing this through an online database. All right, here's just another example. Here's like a known, right? And then here's an unknown. So here is the idea that we know that this has chloride, and we know that when we add the reagent that this will become positive because we know that that chloride maybe is present. This is not uncommon. However, the SOPs will include this information. This is not going to be found in the monograph most of the time. So the monograph is really just going to focus on the test material and nothing more. So a proper laboratory might give you a SOP, and the SOP will be like, hey, take this because we know in this case chloride is present. And because chloride is present, we know you should get a positive test. And you're going to test this along with this substance that you think has chloride there, right? I mean, that's the whole point of this. So that way you can do a quick comparison between a known and an unknown. Just for point of references, just to make sure that the reagents work, just to make sure that you're seeing things the proper way. That's what the knowns are all about. In our 115 class, though, we don't really focus too much On the knowns, we just really strictly follow the monographs, and a lot of times they don't include that. But in real life, they probably will. So just keep that in mind. That is not uncommon. But that is an SOP modification because we need to have an SOP that goes along with this kind of stuff, right? And proper laboratory procedures would be have a cross-reference, have a double check, make sure these tests are actually going to work the proper way before you start passing and failing things left and right. And maybe it's just a bad reagent that you got a hold of that wasn't going to be working properly. Identification test. Currently, folks, there's over 40, and they tend to add to these over a course of time, never take them away. So we're at a total of around 40 as of right now, and that list can continue to grow in the future, but at least 40 of them or more. And they focus on cations and anions. So if you've not had a general chemistry class, that's okay. If you've not taken Chem 151 or 152 or 114, you might not know what the definition of a cation or anion is. So a cation is a positively charged piece, and an anion is a negatively charged piece. So I want you to think of a little bitty atom, and that atom can carry with it a charge. And that charged atom, if it's positive, is cation, and if it's negative, it's anion. I want you to look at cation, and you see the T here. That T looks like a positive symbol to me, and that's how you can keep these two things straight. So cation has the T, and that T looks like a plus, and that plus is a positively charged ion that's swimming around in solutions. Typically, the cations on the periodic table are going to be coming from what we would classify as metals on the periodic table, and the anions are typically going to be coming from the non-metals on the periodic table. So there's going to be more cations than there are anions because there's more chances of us to run across metals that are creating positive charges versus just a handful of non-metals that are on the periodic chart. So if you take a look at the list of the 40, that is what you're going to see. You're going to see a lot of positive representation or a lot of cation representation. Next up are the instrumental identification tests, and that's where I'm going to stop this video. So in the next part of this video, we're going to talk about the instrument piece a little bit more detail. We're going to look at some of the equipment that might show up here. Maybe it's not an all-inclusive list, but we'll at least briefly mention a few things that are going to show up that we need to be maybe comfortable with under the identification portion of the identification test, okay, or the instrumental portion of the identification test. All right, so come back. That's where we'll pick up, and we'll probably finish out this lecture series in the next video. So don't stay away too long. Come back and see me. I don't like to be lonely.